Okay, ladies and gentlemen, luckily there are some ladies here, not very many of them. Okay, my name is Vladimír Smutný. I am from neighboring Czech Institute for Informatics, Robotics and Cybernetics, and we have currently a running project with our industrial customer for disassembly of used EV batteries and reuse them for, let's say, storing of energy purposes for stationary storage. So there is obvious motivation for reusing the batteries because they are pretty expensive, and what is maybe for the future even more important is that there are very resources consuming, I mean particularly lithium and other dangerous components and so on. And of course, EV batteries or the batteries which are used for whatever kind of mobility, starting from bicycles and scooters, etc., there is very high demand on performance of the battery, especially energy stored compared to the mass. So, as was described in the previous talk, the performance of the batteries deteriorates with the time, and also it deteriorates with for example, temperature. And if those two effects are combined, then the range of the EV car can very easily be insufficient for future use. But still, when we reuse the battery for stationary energy storage, then we don't need to fight with, for example, cold temperatures. We don't care about the mass of the battery. And the battery can be used for much longer time than for mobility. There are basically two concepts which are used now. One is that the whole battery taken from the car is put into the shelf, connected to some management and conversion into AC, etc. And then our task, that is disassembly, is not needed. Our customer decided that it will use individual modules. So this is BMW i3 battery, which consists of 8 modules like this. And they would like to disassemble the original battery, check the performance of individual modules, and somehow regrouped the battery into, let's say, new shape and new battery management system, etc. Here is a very brief comparison of what is the difference when the battery is used for electromobility or for energy storage. So the most important is that stored energy per mass, because the battery should be accelerated. So this is a really critical parameter. Of course, operation, especially in low temperatures, is also critical. So the range of the car during really cold weather can go down significantly. And of course, there are some other things, like when the car is staying for a long time in the garage, not moving, not recharging, then there are some other issues. With energy storage, lifetime use of the batteries is very different, and it has very different requirements. Okay, so because we are in quite early phase of the use of electrical vehicles, we can observe how the things developed. So the original idea was to take standard car, remove the engine, remove everything related like exhaust, storage, gasoline storage tank, etc., and instead put their batteries. So one can see like very early attempts how to make EV cars. So you can see that basically they tried to use the space which is already available in the car. So it's in very strange shape. Then let's say the things were going more consolidated. So the battery became more centralized, located under passenger compartment, still copying, for example, the space for legs and the space under the seats in this case. So still the design is somehow strange. And finally, at the current state, almost all new cars have almost rectangular battery pack, which is placed under the passenger compartment. It's very standardized and is very well tuned to assembly on the production line, which is almost automated. So this is just my classification. So 1, 2, 3 generation. This is not what one will find in the literature. So at the very early, the task was, hey guys, put the battery in the car, and the car itself should not change. So the things were done heavily manually. We observe kind of fear of water, which can leak into the battery. So, for example, the lid on the battery compartment was glued to the rest of the frame. There was a little emphasis on thermal management, etc. In the second case, the car body was a little bit adjusted, and also they started to think how to improve manufacturability of the batteries. And what we can observe in current generation is that the manufacturing cost is very important. So the battery is very simplified, it's standardized. It can be now, for example, disassembled non-destructively because the lid is not glued, but lid is only sealed by kind of sealant. And they also started to think about disassembly. And what one can expect in near future is still emphasis on automated production, but also emphasis on disassembly and recycling issues, while of course performance characteristics are still being improved. I have here photos of our disassembly, so I have 2 examples. One example is Nissan Leaf, which I consider kind of intermediate step. you can see that there are, for example, the technologies which are used in car productions, like making the lid and the frame from thin sheets of metal, in this case steel, which are welded together to get the stiffness required, and the batteries inside are connected in a similar way like the car is interconnected currently. You can see that there is a almost mess of wires. The wires are from time to time attached to the frames. So, for example, here or there, this attachment is using like insert and don't disassemble pieces of plastic. The cable assemblies are very similar what one can find in the car, which is basically heavily labor intensive for manufacturing. So the battery cells themselves are kind of standardized, but they are inserted into like vertically in this part or horizontally in this and that part, in 2 layers here, in 4 layers there, and so on. So still kind of messy design. You can see that there are plenty of connectors, plenty, not that many electronics there. Very, very difficult both disassemble, which is not surprising, but I guess that it was also very difficult to assemble it. This is the, let's say, current generation, although BMW i3 is already a long time on the market, but you can see that the design is very different. So there are modules here. Each module has one power cable. This power cable is connected by standard connector. This, for example, the standard connector has a parking slot here, so that when the module is manufactured, stored, distributed, then everything is kind of standardized. There is another view on the battery, so one can see here those 8 modules. Maybe next one is better. This is the power connector here. On the side, lightly attached, is balancing unit, which is connected to the connector of battery. So this is going to individual cells. This connector is going to the central harness, which is connected to BMS, to battery management system. The connectors are very nice. Of course, this would be difficult to disassemble by robot, but still manageable. So the gripper will be complicated, but I can imagine that it can be done, which is uncomparable to this Nissan. In the previous case, where this was, I don't know, 15 different connectors, some of them cable to cable. So even with very clever gripper, with good robots, you will need 2 robots to disassemble this connector. And of course, the specialty of battery assembly and disassembly is that it's all the time under voltage. So cutting the cables for disassembly is not an option for all cables. At least for most cables, it's not an option. So This is the battery, which is much nicer for disassembly than the previous one. Basically, okay. So I have this is the for example the screw on top of the lid, and another screws on the edge of the lid. So the disassembly line we are designing currently, we are going to prepare in Circ the like demonstration disassembly line. It's composed of unscrewing robotic units, manipulation robotic units, manual units, and the transport of the batteries between the individual units is by mobile robots, kind of AGV. And in our simplified case, we will have one screw driving unit or cell, and one manipulation cell, and one manual cell. And actually the order of procedure will be like that. First, the screws on the lid will be unscrewed. The battery will go to manipulation, lid, and the like safety cover will be removed. Then it will go to the second round of unscrewing, where those where those screws will be removed. Then it will go to the manual cell, where the cables will be disconnected manually by the personnel. And then it goes again to unscrewing for other screws, and then the modules will be removed by manipulation unit. So altogether, removing the modules, which are important for this second life battery project, is about 5 or 8 steps. Compared to the Nissan, where the whole disassembly was roughly 150 steps, individual steps, where even the going between unscrewing, manipulation, and disconnecting the connectors will be much more frequent or intensive. So we think that basically the real production plant will also consist of those manipulation units, unscrewing units, robotic manual cells. The manual cells actually will do difficult things like disconnected connectors, but also they will correct what the robotic cells cannot do, like for example, there is a rusty screw and the robot is not able to unscrew it. So then it will be the information will be sent to the manual unit. The human tender will be navigated by kind of Pokayoke system. This screw should be unscrewed manually, and then the procedure will continue. What is the difference between, let's say, assembly line and disassembly line? So for assembly line, the manufacturer has very complete information. So the information is very important. So they have 3D models. They have a known plan. They know that they are currently manufacturing this particular modification of the battery, and typically they produce this modification for a certain time, and then maybe something is improved, and from that time there is kind of n+1 version, and the old version is not manufactured anymore. But for disassembly, the batteries are coming just completely stochastically. So you get newer version, older version. You have mixture of manufacturers in the let's say manufacturing queue and so on. In assembly line, you work with new components, so they are typically free from rust, dirt, paint, whatever can spoil the operation. What is, for example, interesting is that particularly those screws, they don't have prepared holes. So it's so-called self-tapping screws. So they are making the hole and making the thread in a single step. So the position of the future position of the screw is not only determined by the CAD model and the robotic cell who is doing that, but also how it happens. So it can be a few millimeters here and there, even with the standard production plan. But for unscrewing, we should really locate the actual position of the screws. This is okay because this is a combination of Torx screw with hexagon head screw. Hexagon head is much easier to handle by automatic screwdriver. So we will definitely prefer for such screws this hexagon tool. But for this one, there is only Torx tool can be used, and very sensitive to relative position of the screw and the screwdriver. So as I mentioned, there is a typical mass production, but the disassembly, at least this is the plan of our customer, that they will take different batteries from different manufacturers, different types of the cars, and so on. So everything should be much more flexible. And another thing is that the components are optimized for the assembly. So many things are not ready for disassembly at all. This is a very nice example, this Nissan car. We believe that the flexibility is very, very inherent part of the disassembly line. We suggest to our customer combine robotic and manually operated cells. We use autonomous mobile robots for transport among cells, and the whole thing should be controlled by a manufacturing execution system. So that this is the kind of brain which knows about the battery, what is the type of the battery. It sends information to individual robotic cells. It gets the results of operations, whether the operation failed or was successful, etc. And then it transfers this information, for example, to manually operated cell, etc. And what is also very important is that vision and similar systems are needed for navigating the robots to actual positions of individual components, either screws or the modules, etc. Okay, so disassembly is much more difficult than assembly, and it looks like that better design of new assembly is more or will be more suited to disassembly, and the knowledge learned can be used for disassembly other things in future, not only batteries. So thank you for your attention.
Thank you so much for your contribution. And do you have some questions?
I'd like to ask you, who could be a potential customer for these recycled batteries? Where can they be used? And how about the management? I cannot imagine, or the batteries have different states and physical things. So,
what I was told is that the potential user are especially kind of medium size, like industrial customers. So I can tell only what I was told. So I don't know what will be the real result. So potentially, for example, I have a battery for my photovoltaic at home. So they are not speaking about like private customers. They are not speaking about, let's say, Czech or others, big energy producers, but they are probably speaking about companies which would like to have their photovoltaics supported by batteries and so on. How they think they will integrate different modules of different age and so on, so this is not my expertise, unfortunately.
Thank you. And another question? No one. So thank you again.